grade 12s. For this little activity, instead of actually being able to do our electrochemical cell lab, I'm just going to talk our way through it a little bit and then just give you some questions to work on that you could actually do using some of the data that we've already been given. Okay, so again, what we're setting up is called an electrochemical cell. It means we're going to produce electricity using a chemical reaction. What kind of chemical reaction? A redox reaction, where it's a coupled reaction, something gets oxidized and something gets reduced. Okay? So for this one, you would be given 6 or 8 different cells to set up in the lab. You would put the metals in their respective nitrate solutions. You'd hook up the voltmeters, and based on the cell notation, you would be told which one's the anode and which one's the cathode. And then, of course, you're going to get a positive value on your voltmeter. And if you didn't set it up correctly, flip them around and you'll get the positive value. Okay, so you might just not have known which way to set it up. There is a little note in here on how to read one of the voltmeters. You're welcome to read through it and see if you can figure it out. But again, you could just hook up a digital voltmeter as well. Maybe you've used that in physics or in tech class. Same thing, it gives you a reading of the voltage or the amount of electrons that are simply flowing through. Okay, so for the first one, we would have set it up where we've got magnesium and copper, and which one's the anode and which one's the cathode. Where's the oxidation? Where's the reduction? What does that look like? Okay, so based on that, you've got a little setup down here. Okay, so we've got our cell notation. We know that magnesium is going to be the anode, which is the site of oxidation. Okay, and we know that our copper electrode is going to be called our cathode, and that is the site of reduction. All right, we know the electrons are going this way. How many electrons? Magnesium is going to be oxidized. It's turning into magnesium ions. It's an Mg2+. Therefore, you've got a flow of 2 electrons for every atom. Oh, I guess you can't see that. For every atom of magnesium that's flowing, getting oxidized. Okay, what else do we have? We want to show our ions of the copper. What's happening at the reduction site? You are showing that you've got copper ions turning into copper atoms. Which electrode's going to gain in mass? Which one's going to lose mass? This one's going to get smaller. This one's going to get bigger. And then what's going to happen to that charge buildup? There's the nitrates that are going to counterbalance that. Which way are the nitrates going to go? Well, you have nitrates on both sides because the magnesium is in magnesium nitrate. The copper is in copper nitrate. What's the net flow of the electrons? This way, to balance out the positive charge that's building up at the site of oxidation. Okay, what else do I need on here? I think that's all of my labels, okay? All right, so now what would we have done in the lab? We would set these up, we'd have little alligator clips on connecting to the voltmeter, and we would read what the amount of energy is that it's recording as it goes through the voltmeter, okay? So for this little lab activity, I'm going to go through a few of the points. You can read the lab, so whenever you need to pause the video to sort of do a step, I outline this in the lesson, go ahead and do that. I probably said, okay, pause the video and, write up the cell notation and complete the diagram. Pause the video, read the procedure. And now we're at that stage where we're going to be looking at some of the analysis questions, which include filling in a few things on the data table. The only thing I want you to hand in is question number 2 because it has to do with this topic, but the data has nothing to do with the question that you need to submit, okay? I just want to check that if you were to be given a question like this, can you draw a labeled diagram? Can you show me what the reduction potentials would be from the values that are in the textbook? And can you give me the overall E0 value for that cell? And I think there's one more, 2C, you can answer that question as well, okay? All right, so for question number 1, simply I would take just point form notes on this, and then if you want to gather all your information together for this lab, I've suggested you can submit me the whole couple of pages of this, or you can just submit question number 2, whatever you want to do, okay? But definitely you want to go through these questions. So question number 1, easy. Define the terms anode and cathode with respect to oxidation and reduction. Go. Okay, question 1b. This says, I want you to have a look at the observation table. You figure out which one is the oxidation reduction, and I want you to show that. All right, so here's what you're going to do. I want you to have a look at these cells that you would set up. Okay, so imagine magnesium and magnesium nitrate connected to copper with copper nitrate. Which one's the anode? Which one's the cathode? What are the half reactions? What's the overall reaction? And just fill in this table as you go. Okay, so pause the video, write those out for practice, and then play the video and just check your answer with me. So I'll do the first one for you. Magnesium, 2 magnesium, 2 plus, and 2 electrons, because this one is the anode, that is the site of oxidation. My half reaction for the cathode is going to be Cu2 plus 2 electrons going to copper. What's my overall reaction? It's magnesium plus Cu2 plus going to Mg2 plus Cu. Okay, and that's basically all I would have gotten you to do. Show me what that looks like given the cell notation for this one, and this one. And then in the lab, we would have hooked it up, the anode and the cathode, and we would measure the voltage that you get on your voltmeter. Okay? Does this tell you a little something here? You're comparing magnesium to copper, then you're comparing magnesium and iron, and then you're comparing magnesium and zinc. Based on these values, copper, iron, and zinc, 1.65, 1.08, 0.77, which one has the greatest reduction potential? Copper, iron, or zinc? You're comparing them all to magnesium. What do you think? Copper. Okay. What would we have done? We would have taken these values, and then one of the questions in the lab tells you to arrange them in order of decreasing ability to be reduced. Because for another calculation question, we were comparing all of those to magnesium, and those were the values that you got. So if magnesium had an E0 value of 0, what could you say for the other half reactions? This is just a lab question. This is not the value that you would get in the standard reduction potential table. I just want you to see where these values would come down, and the fact that if they were all compared to magnesium, which they are, you could figure out which one has the greatest potential of copper, iron, and zinc, because you're comparing them to the same thing. The one with the greatest value has the greatest potential to be reduced of those three. Okay? Ignore the rest of this. Ignore the rest of this because we would have used some of this data to make a prediction. Okay, pause the video if you need to and come back to the questions. All right, so question number 3. Again, you're going to be doing question number 2A, 2B, and 2C. That you're going to submit to me. Question number 3 was just simply to complete the tables, which we've already just talked about. And then question number 4 is just basically a little calculation question. Remember in the previous video I said if you wanted to calculate the E0 value of a cell, you can do it 2 different ways. You can take the reduction potentials that you get in the table in the textbook, write the reduction as is, take the other one that you know is going to get oxidized, flip it, and add the 2 potentials to give you the overall cell potential. You could also take the reduction potentials for both of them, figure out which one's the cathode and the anode, and then put these values in, and if you take the difference between them, you'll get the same value. You're just calculating it in a different way. Okay, so don't worry about which way is the right way. They are both correct, and you will get the exact same answer. Because in the first method where you take it and you flip the reduction to do oxidation, add them, you'll get the same value if you take both reduction potentials and then take the difference between them because this negative or this negative right here will factor that in. Okay, if you want to ignore that, that's okay, but just so you know, there's another way to do it. Okay, then you're going to move on to question number 5 is another one. This is the last one in here. We wouldn't do 6. We're not going to even talk about number 6 because that was using some fake data. But for this one, question number 5 says, because the measured E0 value is due to the difference in electrical potentials of your two half cells, it's impossible to determine an individual electrical potential without some sort of reference point. Okay? In the table in the textbook, which one is given the 0.00 volts for which element? Do you remember? It's the hydrogen. That's the one that was given to you in the textbook that everything else was compared to. Under what standard conditions? Do you remember what the conditions are that would give you that value? Okay, standard temperature, pressure, and a 1 molar solution. And then questions C and D are ones that we're not going to do either because obviously they have to do with some data from the lab. Okay, so what's our takeaway? Can you use the cell notation to show which one's the anode and the cathode, the site of oxidation, the site of reduction? Could you set it up to figure out how many volts you get? If you were comparing them, could you then determine which one had the greatest reduction potential versus the one that would get oxidized? Could you calculate that? Could you do your balancing? Everything else is pretty straightforward. Okay, so I know that's a lot for this topic. There are some other questions in the textbook. There's the reading from the textbook. And of course, there's the really good videos, Tyler's videos online, that if you want to go back over this topic one more time before we wrap it up, you're more than welcome to do that. Okay, in our last lesson on electrochemistry after you come back from your break for this quadmester, remember, we're going to just kind of finish things up. We're going to be looking at a battery and then how you could make a cell work in the direction you wanted it to go if it was going to be opposite. So there's a few tidying up things we'll do. Okay, so good luck with everything. Let me know how it goes.